linear equations. Remember the definition of a linear equation. The first order differential equation of the form a sub 1x, the rate of change of y with respect to x, plus a sub 0x times y equals to g of x. A sub 1, a sub 0, these are all functions or terms in x, and on the right-hand side you have another function or term in x as well. This is said to be a linear equation in variable y. It means that y depends on x. To solve these types of equations, first we need to write in standard form. Divide everything by a sub 1 of x, you get y prime plus pxy equals to f of x. Then we need to find something that we call the integrating factor. The integrating factor is exponential e to the integral of px dx. The px is the quantity next to your y. After evaluating that, you're going to use the reverse of product rule. You have the rate of change of the integrating factor times y. On the right-hand side, you end up with integrating factor times f of x. Then you take the integral of both sides and solve it. Sometimes you can write the answer implicitly. Some other times you can write the answer explicitly. That depends on the differential equation that you have. So these are the general steps. Please make sure your a sub 1 of x cannot be equal to 0. Otherwise, we don't have division. So be careful about the domain when you're working with these types of equations. So these are the steps, general steps in solving a linear first-order differential equation. Consider this differential equation. You have x times the rate of change of y with respect to x minus y equals to x squared sine x. Our goal is to write it in standard form. So we're going to divide everything by x. You can simplify this as well. You can get rid of x and x. 1x and the exponent get cancel out. You get y prime minus 1 over xy equals to x sine x. So this is written in standard form. Now let us find the integrating factor. The integrating factor is e to power negative integral 1 over x dx. Why is that? Because you have your px, which is negative 1 over x. To find this integral, remember that the integral of 1 over t dt is ln of absolute value of t. So e to negative power integral dx over x can be written as e to power negative ln of x, assuming that x is positive. So we can restrict the domain to have more flexibility and getting rid of the absolute value sign, which in turn is equal to e to power ln of x to power negative 1. E and ln, they get cancelled out. So you end up with x to power negative 1 or 1 over x. Now, following the reverse of product rule, the rate of change with respect to x of the integrating factor times y is equal to sine x. If you take the integral of both sides, the integral and the rate of change, they get cancelled out. You get 1 over x times y equals to the integral of sine x with respect to x, which is negative cosine x, plus c. Now you can do a little bit of algebra. Multiply everything by x and y becomes cx minus x cosine x. So we found the solution for this linear differential equation.